Hello everyone, welcome back to my Java tutorial series. In the previous video, we discussed the major features introduced in Java 8. Today we are going to learn one of the most important Java 8 features, Lambda expression. Lambda expression allows us to write more concise and readable code, especially when working with functional interfaces, collections, and stream API. By the end of this video, you will understand what Lambda expression is, its syntax, how to use parameters and return values, how it compares with anonymous classes. What is lambda expression? A lambda expression is essentially concise way of representing a behavior. The basic syntax consists of parameters followed by an arrow, followed by an expression or a block of a statement. The arrow symbol is called a lambda operator and arrow operator. For example, if you want to add two numbers, we can write lambda expression that takes two parameters and returns their sum. Why do we require lambda expression? Before Java 8, when we wanted to pass behavior as an argument, we often used anonymous classes. This could result in several lines of code for a very simple operation. Lambda expression reduces this boilerplate code. This is especially useful when we work with collection, function interface, and streams. Let us look at the simple example for the lambda. Here we have runnable implemented using anonymous class. We can replace the anonymous class with lambda expression. The lambda version is much shorter and focuses directly on the behavior we want to execute. Now let us understand the syntax. If there are no parameters, we use empty parentheses. If there is one parameter, parentheses are optional. If there are multiple parameters, we normally use parentheses. The arrow separates the parameters from the body of the lambda. Now let us say lambda with no parameters. A lambda can have no parameters. So in this example, empty parentheses indicate that the lambda doesn't receive any input. The body simply prints hello. Now coming to lambda with one parameter, we can omit the parentheses. Both versions are valid. So these two expressions are equivalent. This makes lambda expression very concise. Now coming to the lambda with multiple parameters, we use parenthesis. Here our lambda receives two parentheses a and b and returning their sum. We can write the body as a single expression or as a block containing multiple statement. Now let us see the difference between the expression body and the block body. There are two common ways to write a lambda body. The first is an expression body. The second is a block body. When we use the block containing the multiple statements, we need to explicitly use return keyword if the lambda needs to return a value. Now we can come to the very important concept. A lambda expression doesn't exist independently. It is used with the functional interface. Here we have calculator interface containing a abstract method. We can provide the implementation of the method using a lambda expression. This is relationship between the lambda expression and functional interface. We will study functional interface in detail in our next video. Now let us see how to use lambda with collection. Lambda expression become especially useful when working with the collection. Here we have list of names. Using for which method, we can provide lambda expression that tells Java what to do with each element. This is much cleaner than writing the traditional loop for a simple operation. Now coming to the lambda with comparator. Before Java 8, we commonly use anonymous class with the comparator. With lambda expression, we can express the same comparison logic much more concisely. This is one reason lambda became popular in Java application. Lambda expression can also be used with the threads. Since runnable is a functional interface, we can provide its implementation using lambda expression. This significantly reduces the amount of code needed for the simple thread task. A lambda can also return a value. When the body is a single expression, Java automatically returns the result. When we use the block body, we explicitly use the return statement. Both examples here produces the same result. There is a one more important rule regarding the local variable. A lambda can access the local variable from the enclosing scope, but that variable must be final or effectively final. Effectively final means that we don't explicitly declare it as final, but we don't charge its value after initialization. This is an important interview question. Notice the differences between the lambda and anonymous class. Anonymous classes generally require a more boilerplate code. Lambda expression much more concise, but remember that lambdas are primarily used where the functional interface is expected. So lambda doesn't replace every use case of anonymous class. Here are some important rules of you should remember. A lambda doesn't have method name or an explicitly written type in its normal syntax. It works with functional interface. There are also specific rules around parameters, block bodies, and local variables. These are frequently asked in the Java interviews. In real world Java application, you will see a lambda expression frequently. They are commonly used with the collection, comparators, streams, functional interface, and asynchronous operations. If you work with the modern Java code, understanding lambda expression is essential. Here are some common interview questions. Make sure you understand the concept rather than the simply memorizing the answer. In particular, be prepared to explain the relationship between the lambda expression and the functional interface. Let's summarize today's video. We learned what lambda expressions are and why they are introduced. We include different lambda syntax, parameters, return values, and block bodies. We also saw how lambda work with collections, comparators, and threads. Most importantly, we learned lambda expression works with the functional interface. If you found this video helpful, please like, share, and subscribe to my channel. In the next video, we will learn about next topic. Thank you for watching.